Hopefully, after watching 2 videos on the sliding ladder problem, you guys did not have any trouble with number 9, but I am going to talk about numbers 10 and 11 on page 200 in your textbook. 10 and 11 are the same type problem, except they change a few things up, but it's the same general setup. So if you notice what I have on the board right now, I've actually changed some of my variables because your book, in example 1 on page 195, hopefully you noticed and it wasn't confusing to you, but they used x for this distance from the side of the house to the bottom of the ladder, and they were using h to describe how high up the ladder is on the wall. Okay, so that's how they have it set up, and it's the same type problem where the length of the ladder is 5, and so I'm going to use c equals 5 to represent that distance still. Number 10 says, suppose that the top is sliding down the wall at a rate of 1.2 meters per second. Now, if the top is sliding down the wall at 1.2 meters per second, we're going down at 1.2 meters per second. Once again, I want to point out that 1.2 meters per second is a rate. Your book even says it. So when you see rate, meters per second, that is a change in a distance h with respect to time is 1.2 meters per second. But also, what is very important in this is that this distance right here, h, is getting smaller as this thing slides down the wall. So since the distance is getting shorter as it slides down the wall, this should be negative 1.2 meters per second. Continuing reading, it says calculate dx dt when h equals 3. So they're saying that right now they want h to be equal to 3, and they want us to find dx dt. So we're going to be looking for. The only other rate we have involved right now would be dc dt. But once again, dc dt is 0 because the length of the ladder will not be changing. And the formula that we're going to use is still the Pythagorean theorem. So that means that h squared plus x squared should equal c squared. So this height x, this height h and this length x right here should both square and sum to give us c squared according to the Pythagorean theorem. And so we just simply filled in the information that they gave us. And now in order to get these rates involved, these different rates of change that we have, we need to take a derivative once again with respect to time. So this will be 2h dh dt plus 2x dx dt equals 2c dc dt. And I'm going to use this exact same thing I did last time, where I divide everything by 2 to simplify this equation to h dh dt plus x dx dt equals c times dc dt. And now that we have this formula and all of these measurements that we were already given, we can begin to plug in. So h is 3. dh dt, remember, is negative 1.2 plus, and here again we run into x, and we don't know what x is right now, but we can go up to the information that we were given from the beginning, that h is 3 at this point, c is 5 at this point, and we can use the Pythagorean theorem and say that 3 squared plus x squared should equal c squared, and c is 5, right? So this should equal 5 squared. And you may or may not be able to recognize this right now as a 3, 4, 5 triangle, but it is a special right triangle, a 3, 4, 5, so that if you use the Pythagorean theorem, while you knew h and you knew c, you can find x to be 4. So in our formula down here, I'm going to plug in 4 for x. dx dt is what we're looking for, so we want to leave it in variable form. And then c is 5, and the change in c with respect to time is still 0. So once we have this equation, we've taken our derivative and we've plugged in all the information that we were given. we can begin to do some algebra in order to solve this thing. And so 3 times negative 1.2 should give us negative 3.6 plus 4 dx dt equals 0. So now, in order to get the dx dt by itself, we'll need to add 3.6 to both sides. This will cancel. And so 4 times the change in x with respect to the change in time should equal 3.6. And then dividing by 4 on both sides gives us that the change in x with respect to time at that moment should be 0.9 meters per second. And you can see that this is a positive number, which is a good sign, because if the top of the ladder is moving in a downward motion, this outside piece of the ladder should be moving out, which means this total distance right here should be stretching, it should be getting longer. And so the fact that we have a positive answer is a good sign, because that means that the distance will be getting longer. Number 11 is very similar. We have the same setup here in number 11. We have an h, calling this distance x, and c is equal to 5. And then they say this, h of 0 equals 4. And the top slides down the wall at a rate of 1.2 meters per second. Well, 1.2 meters per second is the change in the height with respect to time. And if it's going down, remember it's negative 1.2 meters per second. So then they ask us to calculate x and dx dt at t equals 2. So we want to find x and dx dt when t equals 2. So all that they're saying here is that time is now 2 seconds rather. But this information that they gave us for h, the only trick in this problem is going to be how you deal with the information that they gave us for h. See, h was equal to 4 at 0. This 0 right here is a time. That is an initial condition. So when everything started, h was 4. But we're asked about what's happening when t equals 2. So we don't need to know what h was when we started. What we're really concerned with is where h is 2 seconds later. We need h of 2. And the way that we can find this is because if h started off at 4, but it's decreasing by 1.2 meters every second, then that means we can do negative 1.2 times 2 because 2 seconds have elapsed. And negative 1.2 times 2 means that this ladder has dropped by 2.4 meters at that point. So from the initial time to 2 seconds, it is dropped by 2.4 meters. So if we do our 4 minus 2.4, then what we get is that this thing is now 1.6 meters high. So our h that we actually want to use in the problem, because it's the h of 2 seconds later, is 1.6 meters. Now the problem asked for a couple of things. One of the first things it asked for was x. And x is actually really easy to find. There's no rate. There's no change in x with respect to t. There's no velocity or any kind of rate of change involved in finding x. So when you find x, it's simply by using the Pythagorean theorem. We know that h squared plus x squared should equal c squared. So if we plug in 1.6 squared plus x squared should equal 5 squared. And we don't need to use a derivative or anything because we're not trying to find the rate of change. So there's no need to involve derivatives for this. So if you use the Pythagorean theorem and solve for x, you will get that x should be 4.74 if we round to the hundreds place, and that is simply a distance, so it's just 4.74 meters. So x equals 4.74 meters. There's the answer to this part, 4.74 meters. Now finding dx dt is a little more complicated, and we actually need to take our formula, the Pythagorean theorem that we had set up, and in order to be able to figure out the rate of change, we need a derivative. The rate of change is going to require us to take a derivative. So if we take the derivative with respect to time, we get 2h dh dt plus 2x dx dt equals 2c dc dt. And I'm once again going to divide by 2's and cancel those everywhere so that we have h dh dt plus x dx dt equals c dc dt. And now we need to plug in all the information that we have. Well, we found that at t equals 2 seconds, h is 1.6 meters, so I'm going to plug in 1.6 for h. The change in the height with respect to time, remember they gave us the change in height with respect to time was negative 1.2 meters per second, so negative 1.2 plus x, and x is actually the first thing that they asked us to find. We found that x is 4.74 meters, so we're going to plug that information in right here, times, and we're actually looking for now dx dt, so we can leave that variable in there since it's the one that we're looking for. And then we have c, which is 5 continuously, which means that dc dt is still 0. So a little bit of algebra and we'll have our answer here. So if I do 1.6 times negative 1.2, this is negative 1.92 plus 4.74 dx dt equals 5 times 0 makes 0. In order to make this work, we're going to need to add 1.92 to both sides. These cancel, and we have 4.74 times the change in x with respect to the change in time is equal to 1.92. And now to get our rate by itself, we will divide by 4.74 on both sides, and we get that the change in x with respect to the change in time at this point should be 0.41 meters per second. Distance over time. It's a rate, the change. And it is positive because x, if h is moving down, then x should be moving out, so this thing should be lengthening. So the change in x with respect to time should be positive. So it is 0.41 meters per second.